Lab 3 for Physics 1. So the purpose of this lab was to find the unknown mass of a black hole and then use this mass in order to calculate the trajectory of a planet. And the ultimate purpose is to learn about the force of gravity and orbital mechanics, as well as momentum using a simulation. So the main physics principles and equations you can see are kind of listed here. It's basically just force net equals change in momentum over change in time, and then you can kind of see that you can break up force net into force parallel and force perpendicular, and you can kind of do the same for the momentum. You can break it up into momentum parallel and momentum perpendicular. And we also use the equation for the force of gravity to calculate the mass often. So yeah, we calculate Fnet, Fnet par, and Fnet part in order to calculate the average mass of the black hole. And these are kind of our results from part 1. This is the mass of the black hole, the net force, the parallel force, and the perpendicular force. For part 2, we calculated Fnet on the planet and the spaceship using the gravity formula I mentioned earlier, and update position and velocity for each delta t. The initial velocity was guessed through trial and error. So this is the velocity that works for my seeded black hole. So the methodology I used for part 1 in the computer simulation was that first I computed momentum, and then I just kind of used that to compute dp dt, since I had the change in momentum, the change in time. And then I used it to I calculated the parallel and perpendicular aspects of that, and since we know that force net is equal to the parallel and perpendicular aspects, once you break force net parallel and force net perpendicular down, you can kind of set those equal to each other, and you can say force net equals dp dt. And then in the last step, I used all these values I got, like force net, in order to calculate the mass. And then for part 2, I simply just calculated the forces on the planet and the ship. I added them up, and then I used those forces to update the position of both the planet and the ship by calculating the velocity and position and updating it every delta t. So quick talk about the initial conditions. The system is a black hole and the star in a simulation. You can kind of see these are some constants that were entered in: gravitational constant, star to m, the delta t, first observation. And similar for the second one, you can kind of see there's an initial mass for the ship and the planet, which are just kind of given, and then the gravitational constant, delta t. So yeah, so the possible sources of error is that for part 1, the average mass is estimated and calculated every delta t, so it is not an exact calculation of mass. No, it is an exact calculation of the average mass, but not of mass itself. An estimated mass was used in part 2 from part 1. Also, since the speeds are very high and the mass of the black hole is very high, it's possible that Newtonian physics may not perfectly describe the system. So the difference between net force and rate of change of momentum is that even though they are the same value, they are calculated and understood in different ways as concepts. So net force, they equal each other in terms of value, but not in terms of what they are. Force is kind of implied and deduced, while momentum was explicitly calculated by seeing the the impulse. And then the value from trial and error for the what if question is negative 600 620,000 and 395,000 for the shift speed.